Hey dears, welcome to my today's sessions. In this series of DSA tutorials, data structures and algorithms tutorials, I apologize for being failed to upload, but I promise to ensure you that I will include all tutorial videos on all topics, different topics what I have left, like uh, stack, queue, linked list, doubly, singly linked list, even including more topics as your requirements. So please comment me about your topics what you want. But before that, please value my such hard work I have done during this tutorials. I need your small support, simple supports to subscribe, like, comment and share for more videos. So let's start about today's sessions. Tree in data structures. Tree data structures. What is tree data structures? That I will include. But before that, I would like to take you about the linear and non-linear data structures. But before, we have already included, I think, about this linear and non-linear. If not, then I will include, I'm sure. I would like to ensure you. So let's just in simple and types of, if you talk about the types of structures, there are two types of data structures based on this means hierarchy or numbers of branches and non-branches. So that is linear and non-linears. So let's in short, if you'll go through this, there are two types of data structures based on branch or means sequence. One is linear data structures, another is non-linear data structures. In linear data structures, we can find the all elements are arranged, organized in a linear, in a line, in a sequential order, for an example, we can say that array, stack, queue, linked list. So these are an example of linear. They are, these all elements, all nodes are organized in one sequential order. And another hand, in next hand, like we can find that non-linear, in non-linear data structures are not organized in single sequence or in single line. They are in branch, they are in hierarchy order, such as we can say the tree, graph and map. So our tree, we are going to discuss about the tree. Tree is a non-linear, so we will go with this all in more. So when you talk about the tree, so normally in our like in outside the world, you can find tree. When we say the tree, in tree we can find leaf, we can find stems, we can find branches, different branches is trunk, and then even we can find root. Okay, and here also almost, but when we will do the opposite, here we are going to find one hierarchical orders. So root provides to all leaves some materials, like here also, and it's observe some product, means output from the leaf. Okay, so in basically, according to our course, according to our tree, we are talking about the data structures, how we are going to. So like tree is a hierarchical data structures and follow the parent-children relationships. Also, we can say that tree, when we talk about the tree, it's really it is a non-linear hierarchical means one hierarchy. Like some organizations, we can find there will be CEO, and then directors, managing directors, or maybe other line directors and other, and then in charge, then staffs, and maybe their peon and some others. So there will be one particular hierarchy, one after another. Here also we can find, when we talk about, like one will be the parent, grandparent maybe, and then children's, or maybe children's, and then more down. So here also we can find trees, kinds of hierarchical nodes connected by using the line, that is also called edge. Okay, that edge. So I will discuss about this all terminologies clearly. So a tree data structures is a hierarchical order. Repeatedly I am talking about the hierarchical order, where we can find the linked with other childrens. So when we talk about the trees, okay, so we have to remember that like it consists of finite of sets of elements, or that is called also node. Okay, so finite of, and that all finite nodes are connected through the lines, that is called edge, or even we can say the branches. Okay, and the numbers of branches associated with like some particular degree of node, that is also called subtrees. We can find the subtrees, or maybe as some degree of nodes. And also we can say that by the way, tree can be defined in two different ways method, according to the methods of the how we can organize different methods. One is non-recursively, another is recursively. When we talk about this recursively, before also we have other another topics, but I am sure I ensure you to I will make about this recursive, but we are not going to discuss about this all more. So here we are going to discuss about the non-recursive definitions, non-recursive methods, non-recursive techniques, because it is the direct techniques, so where we can organize or formulate our trees by using the simple algorithms, okay, and to manipulate the trees. So let's some more features. When you talk about the some more features like about the tree, here we can find, I told you I will go through that all different techniques, all different. So here one will be the root, main roots. It is also known as the key value. Every node has generally three elements, three components in a node in a single structure. By using these structures we will include, so one will be the data. That data is main root. This one we have one, you can see that okay, so here we can say that, okay, so this main a is the root. So root has some values like a, so that is called key. So this main root node, and here it's linked, it has the link branch also called edge, that helps to connect to another node or next node. Suppose b, here is the b is another node, and maybe here is c is another node. If this node have no child, means down no any node are connected, then they are known as leaf. But now this is the level 0. We can, when we talk about this level 0, and another level 1, level 2 it goes, and if it included another, now another childs, so these down nodes are connected by using edge, different edges, and these are called child or children of b. So b is the parent now. Okay, so b is the parent, because this just immediate successors are like d and e are immediate successors of b. So these are known as children, and then predecessors are parents, immediate predecessors. So label 2 is this. So in this way we can include this all, so you can find here parents. Now let's talk about the subtree. When you this in the same label, nodes, same labels of childrens are called sibling. Okay, so sibling. And if there are more, like includes like this, if this again, now d is the another parent of, here e and f, I have repeated dd, so here you can find. So in this way we can find these are, they have the different childrens, these all different childrens, and this is the another label, but f does not have the childrens, so we can include these are the leaf. So those who does not have any children, they are known as the root. So here this I have one triangle, and triangle is included here three nodes, that is subtree. Or you can not only this, you can include this up to this down level 3. level 3, this all include the subtree, or maybe here also this subtree, this will be the subtree. So there will be the numbers of subtrees if you go with this all. When you separate this all subtree, subtrees, maybe left subtrees, right subtrees, these all different subtrees, they are called forest. If you separate from the main tree, they are known as the forest. So here we can find these all are the leaves. Even f has no child, so this is also included as the leaf. So I have practically here shown with the graphically. So this is the height of the tree, so it's include the length from root to leaf. The highest or longest length of the path is called the height of the tree. So let's theoretically we can go with this all. So node is an entity that contains a key value and two pointers. One is left, another is for right node. Okay, so linked to the right and left node, we have two pointers in a single node. And edge is the connections. I have told you this line, so it is the connections of one node to another node, or a line between two different nodes that connects, that navigate with. Okay, and key value represents the main point or main value of the root node, okay, that carried out by the nodes. So if here is the one, if you separate this all, b is one value, so b can be a key, c can be a key. So these are the different values based on different nodes. Now root node is the node who does not have any parent, or which does not have any predecessors, which is the topmost node is the root node here. Okay, and when we talk about the parents, I have already discussed. So parents have children, so immediate predecessors of any child, any labels, that they are known as parent. But those who are immediate successors and without any children, they are leaf. So here children's, the immediate successors and predecessors, here we have two words. Please remember that predecessors means of. So b is the predecessor of d and e, and d and e are the successors of b, or even we can say h and I are the successors of d. So in this way you can include. So these all child and parents, successor and predecessors. Leaf nodes or external nodes. These leaf nodes also called external nodes or terminal nodes, the nodes which does not have any child, no child at all. So here you cannot find any child. And siblings means same labels, same parents are called maybe as children or maybe as a parent, are known as the sibling. Internal node, the node which have at least one child or children's, two children's or three children's. At least one child is the internal node. An ancestor, when you talk about the ancestor, for an example, when you talk about the ancestor of E, according to example, E means ancestor means or father, grandfather, yeah, these are the ancestor. So when you talk about the E, is parents is B parents is A. So we can find the ancestors of E are B and A. And descendant means just successors nodes after. Okay, so we can find till the leaf, from the leaf to that particular nodes, from the successor to the node. So these are, suppose here E and I are the descendant of B, also we can say up to the leaf. And soft trees, I have already included here. Soft trees is one branch, also we can say. Path is the way to the lift, route to lift, or particular parent to leaf, that are source or path to the destinations node. They are known as the path. Okay, so this is still we have like neighbor of the nodes. So when we talk about this terminologies we have to know about to furthermore. Okay, so neighbor of the nodes means child, we can say side by side as the siblings. And level of nodes, the level of nodes actually I have shown you in my graph. There were the level 0 at the topmost, and then level is the root is always level 0. Sometimes we can find level 1 also, but we can by default we can use as level 0, level 1, level 2, level 3 is the different levels we can go with. So it also count the age of the numbers of age of the tree for the level. And height of the tree, when you talk about the height of the tree is the longest part of the node to the leaf, from particular parent to leaf or root to leaf. The longest path is defined as the height of tree. So depth of node. When to talk about the depth of node, we have to remember from root to that particular numbers of edge to the particular nodes. Maybe depth of one single branch will be there, or depth of whole tree also will be there. So we have to remember that how many numbers of edges are included from root to that particular nodes are the depth of node. And degree of node also, the numbers of branch, total numbers of branch, how many branches are there, that is the degree of node. And then forest, the collections of adjoining trees, means how many branches are there, that all branches including one forest. I told you when we'll separate that, when we'll cut that all, they are known as the branches. So we'll talk about these branches as well as graphically, so that it will be clear. So visiting means checking the nodes one after another by controlling on the nodes. And traversing, maybe we have already gone through this. Traversing means like passing through one node to another in a specific order. Like for traversing, we have three different methods of traversing: in order traversing, pre-order traversing, and post order traversing. We'll discuss about this all traversing in next. So let's we have here one example. So when you talk about the height and degree, so here you can find, so degree is always labels, it's count the labels, count the age. So here you can find the this degree is always in root is 0. And height, those who have no child, from there we can find the height. So height includes the numbers of labels as child, from child to nodes. So these are the opposite counting. And suppose here one I have 3, 1 2 3, this I have 3, and when you cut this all in all separate from here, so when we'll separate this all, this is another part, another sub tree, this is another root sub tree is called also forest, and this is another sub tree, only one tree, that is also called tree or forest. So properties of the data structures in tree data structures. So it must be numbers of age. So numbers of age there will be, that is which is helps to define the total numbers of nodes, and then height and degree of the node. Okay, so here we can find the numbers of age. Numbers of age it can be counted to, if tree has n nodes, then it have we can find n minus 1 edges. Okay, edges, numbers of edges. And another depth of nodes. So while talking about the depth of nodes, we can find that each nodes add 1 units, 1 by 1, like 1 unit. And then longest path, now when we'll count with the longest part, it helps to count the numbers of nodes. Height of nodes, height of nodes also is the longest path from leaf node to the tree, a particular parent node or the root node also you can say, height of the tree and height of the node. So here are two different. Height of the node is from leaf to root, but height of the node is particular node to the leaf. And a degree of node, when you talk about the degree of node, I told you degree of node is always in root, always 0, and as it goes to the leaf, it must be included +1 +1. So that is also help to count the height of or degree of the tree. And now applications of the data structures, it is lengthy, going to be lengthy, so because I'm talking about this all application, but I will go a little faster. So binary search tree are used quickly. We will talk about this binary search tree separately in another video in detail. We will go through like this all different operations of binary search trees, even heap, and even different versions, different types of trees. And then but even when talk about the applications like heap kinds of tree that is helps to sort the data. So for that it is used, it is the use of trees. And then most popular database use B tree and tree trees, okay, AVL. So these all can be used for trees. Sorry, a tree can be used in this area. So compilers use syntax trees to validate the syntax of every programs you write. File systems, like we can find some other different types of files that can be efficiently navigate and organized, that all files in proper order, in hierarchical orders. Advantages and disadvantages, when we talk about these trees, we can find here clearly, like tree offers efficient sorting depending on the types of trees. Like we have all different types of trees like BST, AVL. So and tree provides the hierarchical representations of data that it gives one navigations also, and helps to easy to search any other any nodes or any value. The recursive natures of the trees makes them easy to traverse and manipulate using the recursive algorithms. And disadvantage, when you talk about the disadvantage, like unbalanced trees are there. So for unbalanced trees, and it's a very difficult to go through to find the one node to another node. And it maybe help to skew that to the left or skew to the right. So that also one disadvantage. Also we can say tree demands more memory space requires than the, yeah, of course we can find in one single node we have three different values, like one is data and two pointers that helps to connect or linked to right node and left node. So it occupies the more space. And the implementations of manipulations of trees can be complex and requires a good understanding of the algorithms. Of course this requires more clear logic, then only you can understand. So basic operation, we'll go through the basic operations. I think this create, insert, search, travel, so I have talked about this all. So we'll discuss this all in separate video in detail, so that I think it will be clear, because this pre-order traversals, this in order traversals, they requires much. So when you talk about the simple node structures, how we can find these structures, how we can create these structures. So there will be three elements we can find in each nodes. Like one is the data value, another is left child node for the left child, and another for right child, so that we can link to particular node. Okay, so this much in this video we will discuss about these basic operations. Even I am going to talk about some more. So thank you.